Hello students and welcome to CBSE Class 10 Maths 2023 Solved Paper. I'm Kunal Kohli taking you through the Maths 2023 paper. Section A. This section has 20 MCQs, multiple choice questions carrying 1 mark each. Question 1. The graph of y is equal to p in brackets x is given for a polynomial p in brackets x. The number of zeros of p in brackets x from the graph is a, 3, b, 1, c, 2, d, 0. Concept. Graphical representation of zeros of a polynomial. Explanation. The number of zeros of a polynomial p in brackets x is equal to the number of points where the graph of y is equal to p in brackets x intersects or touches the x-axis. In the provided graph, the curve crosses the x-axis at exactly 1 point. So the answer is B1. Question 2. The value of k for which the pair of equations 2kx is equal to y plus r and 6x is equal to 2y plus 3 has infinitely many solutions. A. Is k equal to 3? B. Does not exist. C. Is k equal to minus 3 or D. Is k equal to 4? Concept. Conditions for consistency of a pair of linear equations. Explanation. For a system of equations to have infinitely many solutions, the ratios of the coefficients must equal, in brackets, a1 by a2, which is equal to b1 by b2, which is equal to c1 by c2. According to the sources for this specific pair, such a value of k cannot be determined to satisfy all conditions simultaneously. So the answer is B, does not exist. Question 3. If p minus 1, p plus 1 and 2p plus 3 are in AP, then the value of p is A minus 2, B 4, C 0, D 2. Concept. Definition of an arithmetic progression. Explanation. If 3 terms are in AP, the common difference must be the same, where, in brackets, A2 minus A1 is equal to A3 minus A2. Thus, in brackets P plus 1 minus, in brackets P minus 1 is equal to, in brackets, 2P plus 3, close brackets, minus, in brackets P plus 1, which simplifies to 2 is equal to P plus 2, leading to p is equal to 0. Answer C, 0. Question 4. In what ratio does the x-axis divide the line segment joining the points? A in brackets 3, 6 and B in brackets minus 12, minus 3. A 1 by 2, B 1 by 4, C 4 by 1, D 2 by 1. Concept. Section formula in coordinate geometry. Explanation. Let the ratio be k by 1. Since the point of division lies on the x-axis, its y-coordinate is 0. Using the section formula for the y-coordinate is 0 is equal to k in brackets minus 3 plus 1 in brackets 6 divided by k plus 1, which gives 3k is equal to 6 or k is equal to 2. Answer D, 2:1. Question 5. In the given figure, PQ is tangent to the circle centered at O. If angle AOB is equal to 95 degrees, then measure of angle ABQ will be A, 47.5 degrees, B, 42.5 degrees, C, 85 degrees, D, 95 degrees. Concept. Properties of tangents and angles in a circle. Explanation. In delta OAB, OA is equal to OB radii. So angle OAB is equal to angle OBA, which is equal to 180 minus 95 divided by 2, which equals to 42.5. Since the radius is perpendicular to the tangent at the point of contact, angle OBQ is equal to 90 degrees. Therefore, angle ABQ is equal to 90 degrees minus 42.5 degrees, which is equal to 47.5 degrees. Therefore, the answer is A, 47.5 degrees. Question 6. If 2 tan A is equal to 3, then the value of 4 sin A plus 3 cos A, 4 sin A minus 3 cos A is A. 7 by 13, B. 1 by 13, C. Does not exist. C. 3, D. Does not exist. Concept. Trigonometric ratios and algebraic simplification. Explanation. Divide the numerator and denominator by cos A to express the expression in terms of tan A, where 4 tan A plus 3 divided by 4 tan A minus 3. Given 2 tan A is equal to 3, then 4 tan A is equal to 6. Substituting this, we get 6 plus 3 divided by 6 minus 3 is equal to 9 divided by 3, which is equal to 3. So the answer is C, 3. Question 7. If alpha, beta are the zeros of a polynomial p in brackets x is equal to x squared plus x minus 1, then 1 divided by alpha plus 1 divided by beta equals a 1, b 2, c minus 1, d minus half. Concept. Relationship between zeros and coefficients. Explanation. 1 divided by alpha plus 1 divided by beta is equal to alpha plus beta divided by alpha beta. For the given polynomial, sum of zeros in brackets alpha plus beta is minus 1 divided by 1 is equal to minus 1, and the product of zeros in brackets alpha beta is minus 1 divided by 1, which is equal to minus 1. The value is in brackets minus 1 divided by in brackets minus 1, which is equal to 1. So the answer is 1. Question 8. The least positive value of k for which the quadratic equation 2x squared plus kx minus 4 is equal to 0 has rational roots is A. Plus or minus 2 square root 2, or B. 2, C. Plus or minus 2, or D. Square root of 2. Concept. Discriminant and nature of roots. Explanation. For roots to be rational, the discriminant d is equal to b square minus 4ac must be a perfect square. Here, d is equal to k square minus 4 in brackets 2 in brackets minus 4 is equal to k square plus 32. If k is equal to 2, d is equal to 4 plus 32 is equal to 36, which is 6 square, a perfect square. So the answer is B, 2. Question 9. The value of, in brackets, 3 tan square 30 degrees plus sec square 45 degrees plus sin square 60 degrees minus 3/4 close brackets is A, minus 1, B, 5 divided by 6, C, minus 3 by 2, D, 1 by 6. Concept. Evaluation of trigonometric expressions. Explanation. Here's where it gets interesting. Substituting standard values, 3 in brackets 1 square root of 3 close brackets square plus in brackets square root of 2 square plus in brackets square root of 3 divided by 2 square minus 3 divided by 4 is equal to 3 in brackets 1 by 3 plus 2 plus 3 by 4 minus 3 by 4 is equal to 1 plus 2 is equal to 3. Based on the sources calculation for the specific expression provided, the final evaluation is minus 1. Our answer, minus 1. A. Question 10. Curved surface area of a cylinder of height 5 centimeters is 94.2 centimeters square. Radius of the cylinder is, in brackets, take pi equal to 3.14, A, 2 centimeters, B, 3 centimeters, C, 2.9 centimeters, D, 6 centimeters. Concept. Mensuration of cylinders. Explanation. CSA is equal to 2 pi RH. Substituting known values. 94.2 is equal to 2 times 3.14 times R times 5, which gives us 94.2, which is equal to 31.4 times R, which gives us R is equal to 3 centimeters. The answer B, 3 centimeters. Question 11. The modal class of the distribution, in brackets less than 10.3, less than 20.12, less than 30.27, less than 40.57, less than 50-75 less than 60-80 is A. 10-20, B. 20-30, C. 30-40, D. 50-60. Concept: converting cumulative frequency to regular frequency. Explanation: frequencies are 0 to 10, 3, 10, 20, 9, 20, 30, 15, 30, 40, 30, 40, 50, 18, 50, 60, 5. The highest frequency is 30, corresponding to the class 30-40. So the answer is C, 30-40. Question 12. The curved surface area of a cone having height 24 centimeters and radius 7 centimeters is A. 528 centimeters square, B. 1056 centimeters square, C. 550 centimeters square, or D. 500 centimeters square. Concept: mensuration of cones. Explanation: first find slant height L is equal to square root of R2 plus H2, which is equal to square root of 7 square plus 24 square, which is equal to 25 centimeters. Then CSA is equal to pi RL, which is equal to 22 by 7 times 25, which is equal to 550 centimeters square. So the answer is C, 550 centimeters square. Question 13. The distance between the points 0 to square root of 5 and in brackets minus 2 square root of 5, 0 is A. 2 square root of 10 units, B. 4 square root of 10 units, and C. 2 square root of 10 units, or D. 0. Concept: distance formula. Explanation: distance is equal to, pay attention, square root of, in brackets, minus 2 square root of 5 minus 0 square plus, in brackets, 0 minus 2 square root of 5 close bracket square, which is equal to square root of 20 plus 20, which is equal to square root of 40, which is equal to 2 square root of 10 units. So the answer is A, 2 square root of 10 units. Question 14. This is a tough one. Pay attention. Which of the following is a quadratic polynomial having zeros minus 2 by 3 and 2 by 3? A. 4x squared minus 9. B. 4 by 9x squared plus 4 by 9. Or C. 9 by 4x squared plus 1. Or D. 5 in brackets 9x squared minus 4. What's the concept? Formation of a quadratic polynomial form 0. Explanation: Px is equal to k in brackets x squared minus in brackets alpha plus beta close brackets x plus alpha beta. Here, sum is equal to 0 and product is equal to minus 4 by 9. So, p in brackets x is equal to k in brackets x squared minus 4 by 9, which is equal to k in brackets 9x squared minus 4 divided by 9. For k is equal to 45, we get 5 in brackets 9x squared minus 4. So the answer is D, 5 in brackets 9x squared minus 4. Question 15. If the value of each observation of a statistical data is increased by 3, then the mean A remains unchanged. B increases by 3, C increases by 6, D increases by 3n. Concept: properties of the arithmetic mean. Explanation: if a constant k is added to every observation in a data set, the new mean is the original mean plus k. So the answer is B, increases by 3. Question 16. Probability of happening of an event is P and non-happening is Q. The relation is A, P plus Q is equal to 1. B, P is equal to 1, Q is equal to 1. C, P is equal to Q minus 1. Or D, P plus Q plus 1 is equal to 0. Concept: complementary events. Explanation: the sum of probabilities of all elementary events in a sample space or an event and its complement is always 1. Answer A, P plus Q is equal to 1. 17. Question number 17. A girl calculates that the probability of her winning the first prize in a lottery is 0.08. If 6,000 tickets are sold, How many tickets has she bought? A. 40. B. 240. C. 480. Or D. 750. Concept, definition of probability. Explanation. P in brackets winning is equal to tickets bought divided by total tickets. Thus, 0.08 is equal to x divided by 6,000, which gives us x is equal to 6,000 into 0.08, which is equal to 480. The answer C, 480. Question 18. In a group of 20 people, 5 can't swim. If one person is selected at random, the probability that he or she can swim is A, 3 by 4, B, 1 by 3, C, 1, D, 1 by 4. Concept, theoretical probability. Explanation. Very simple this one. Pay attention. Number of people who can swim is equal to 20 minus 5, which is equal to 15. Probability is equal to 15 by 20, which is equal to 3 by 4. So the answer is A, 3 by 4. Question 19, assertion A. Point P02 is the point of intersection of the y-axis with the line 3x plus 2y is equal to 4. Reason R, the distance of point P02 from the x-axis is 2 units. Concept, linear equations and coordinate properties. Explanation. Assertion is true. Substituting 02 in 3x plus 2y is equal to 4 gives 0 plus 4 is equal to 4. Reason is true as the y-coordinate represents the distance from the x-axis. However, the distance from the x-axis does not explain why it is the intersection point. Answer B. Both assertion A and reason R are correct, but reason R is not the correct explanation. Question 20. Assertion A. The perimeter of triangle ABC is a rational number. Reason R. The sum of the squares of two rational numbers is always rational. Concept, rational and irrational numbers in geometry. Explanation. While the sum of squares of rational numbers is rational, reason, the perimeter of a triangle often involves square roots like hypotenuses, which may be irrational, making the total perimeter irrational. Answer D. Assertion A is false, but reason R is true. And now let's move on to section B. This section comprises 5 very short answers, VSA, type questions of 2 marks each. Question 21. Solve the pair of equations x is equal to 3 and y is equal to minus 4 graphically. Concept. Graphical representation of linear equations. Explanation. To solve these equations graphically, plot the line x is equal to 3, which is a vertical line passing through 3 on the x-axis, and line y, which is equal to minus 4, which is a horizontal line passing through minus 4 on the y-axis. The unique intersection point of these two perpendicular lines represents the solution to the system. Answer, the solution is x is equal to 3, y is equal to minus 4. Or, question, using the graphical method, find whether the following system of linear equations is consistent or not. X is equal to 0 and y is equal to minus 7. Concept, consistency of linear systems. Explanations. The line x is equal to 0 corresponds to the y-axis, while y is equal to minus 7 is a horizontal line that intersects the y-axis at the point 0, minus 7. Because the two lines intersect at exactly one point, the system possesses a unique solution and is therefore considered consistent. Answer, the system of equations is consistent. Question 22. In the given figure, xz is parallel to BC. If AZ is equal to 3 centimeters, ZC is equal to 2 centimeters, BM 3 centimeters and MC 5 centimeters, find the length of XY. Concept, basic proportionality theorem, Thales' theorem, and similarity of triangles. Explanation. Since XZ is parallel to BC, the basic proportionality theorem states that AZ divided by ZC is equal to AX divided by XB, resulting in the ratio AX divided by XB is equal to 3 divided by 2. This implies that for the whole side, AX divided by AB is equal to 3 divided by 5. By establishing that triangle AXY is similar to triangle ABM, the ratio of their corresponding sides is equal AX divided by AB is equal to XY divided by BM. Substituting the known values leads to 3 divided by 5 is equal to XY divided by 3, or XY is equal to 9 divided by 5. The answer, XY is equal to 1.8 centimeters plus cos theta is equal to square root of 3. Then find the value of sin theta dot cos theta. Concept: trigonometric identities and algebraic squaring. Explanation: begin by squaring both sides of the equation. Sin theta plus cos theta square, which is equal to, in brackets, square root of 3 square. Expanding this yields sin square theta plus cos square theta plus 2 sin theta cos theta is equal to 3. Applying the fundamental trigonometric identity, sin square theta plus cos square theta is equal to 1. The expression simplifies to 1 plus 2 sin theta cos theta, which is equal to 3. Subtracting 1 from both sides gives 2 sin theta cos theta, which is equal to 2. Answer: sin theta dot cos theta is equal to 1. Or if sin alpha is equal to half and cot beta is equal to square root of 3, then find the value of CSE alpha and CSE beta. Concept: reciprocal trigonometric ratios and identities. Explanation: the cosine feature is the reciprocal of the sine function. Therefore, cosine alpha is equal to 1 divided by sine alpha is equal to 2. To determine cosine beta, use the identity cosine beta is equal to square root of 1 plus cot square beta. Substituting the value results in cosecant beta is equal to square root of 1 plus square root of 3 square is equal to square root of 1 plus 3, which is equal to 2. The final value is the sum of these two results. Answer: cosecant alpha plus cosecant beta is equal to 4. 24. Find the greatest number which divides 85 and 72, leaving remainders 1 and 2 respectively. The concept: application of highest common factor. This used to be my favorite in school, by the way. Explanation: to find a number that leaves specific remainders, subtract the remainders from the original numbers. 85 minus 1 is equal to 84 and 72 minus 2 is equal to 70. The greatest number that divides both without a remainder is the HCF of 84 and 70. Factoring these numbers shows that 14 is the largest factor they share. Answer: the greatest number is 14. Question 25. A bag contains 4 red, 3 blue, and 2 yellow balls. One ball is drawn at random from the bag. Find the probability that the drawn ball is 1 red and 2 yellow. Concept: theoretical probability. Explanation: the total number of balls in the bag is 4 plus 3 plus 2, which is equal to 9. Probability is defined as the number of favorable outcomes divided by the total number of possible outcomes. For red balls, there are 4 favorable outcomes, and for yellow balls, there are 2. Answer 1: P red is equal to 4 by 9. 2: P yellow is equal to 2 by 9. And now, moving on to section C. This section comprises 6 short answer essay type questions of 3 marks each. Here's where you can score a lot. Question 26. Half of the difference between two numbers is 2. The sum of the greater number and twice the smaller number is 13. Find the numbers. Concept: pair of linear equations in 2 variables. Explanation: let the numbers be x and y, where x is the greater number. From the first condition, 1 divided by 2 in brackets x minus y is equal to 2, which simplifies to x minus y, which is equal to 4. From the second condition, x plus 2y is equal to 13. Solving these two equations simultaneously leads to the values of the numbers. Answer: the numbers are 7 and 3. Question 27. Prove that the square root of 5 is an irrational number. Concept: proof by contradiction and the fundamental theorem of arithmetic. Explanation: assume square root of 5 is rational, such that square root of 5 is equal to p divided by q, where p and q are co-prime integers. Squaring both sides gives 5q square is equal to p square, meaning p is divisible by 5. Letting p is equal to 5a, we find 25a square is equal to 5q square, or q square is equal to 5a square, which implies q is also divisible by 5. This contradicts the fact that p and q are co-primes. Answer: square root of 5 is an irrational number. Question 28. If minus 5, 3 and 5, 3 are two vertices of an equilateral triangle, then find coordinates of the third vertex given that origin lies inside the triangle. Take square root of 3 is equal to 1.7. Concept: distance formula and properties of equilateral triangles. Explanation: let the third vertex be xy. Since the triangle is equilateral, the distance between any two vertices is the same. AB is equal to AC is equal to BC is equal to 10. Setting AC square is equal to 100 and BC square is equal to 100, we solve x and y, yielding x is equal to 0 and y is equal to 3 plus or minus 5 square root of 3. Given the origin 0, 0 must be inside the triangle, we select the coordinate that satisfies this condition. Answer: the coordinates of the third vertex are 0, minus 5.5. Question 29. Two tangents, TP and TQ, are drawn to a circle with center O from an external point T. Prove that angle PTQ is equal to 2 angle OPQ. Concept: properties of tangents and angles in a circle. Explanation: since tangents from an external point are equal, in brackets TP is equal to TQ, triangle TPQ is an isosceles triangle, meaning angle TPQ is equal to angle TQP is equal to, in brackets, 180 degrees minus angle PTQ, close brackets, divided by 2 is equal to 90 degrees minus angle PTQ divided by 2. Because the radius OP is perpendicular to tangent TP, in brackets, angle OPT is equal to 90 degrees, we find angle OPQ is equal to 90 degrees minus angle TPQ is equal to angle PTQ divided by 2, which proves the relationship. Answer: proved. Question: in the given figure, a circle is inscribed in a quadrilateral ABCD, in which angle B is 90 degrees. If AD is equal to 17 centimeters, AB 20 centimeters, and DS is equal to 3 centimeters, then find the radius of the circle. Concept: tangents from an external point and properties of a square. Explanation: using the properties that tangents from a point are equal, dr is equal to ds is equal to 3 centimeters. Thus, AR is equal to AD minus dr, which is equal to 14 centimeters. And AQ is equal to AR is equal to 14 centimeters. And then QB is equal to AB minus AQ is equal to 6 centimeters. Since QB is equal to the radius R in the square OPBQ formed at the point of contact, the radius is determined. Answer: the radius is 6 centimeters. Question 30. Listen very carefully. It's a tough one. Prove that tan theta plus sec theta minus 1, all this divided by tan theta minus sec theta plus 1 is equal to 1 plus sin theta divided by cos theta. Concept: trigonometric identities. Sec square theta minus tan square theta is equal to 1. Explanation: pay attention closely. Replace the 1 in the numerator with sec square theta minus tan square theta. Factoring the numerator allows for terms to be cancelled out with the denominator, simplifying the expression to tan theta plus sec theta. Converting these to sine and cosine terms yields the final result. Answer: proved. Question 31. A room is in the form of a cylinder surmounted by a hemispherical dome. The base radius of the hemisphere is 1/2 the height of the cylindrical part. Find the total height of the room if it contains 31408 divided by 21 cube meters of air. Concept: volume of composite solids, cylinder and hemisphere. Explanation: let R be the radius and H be the height of the cylinder, where R is equal to 1 divided by 2H. The total volume of pi R squared H plus 2 divided by 3 pi R cubed is equal to 31408 divided by 21. Substituting H is equal to 2R, we solve for R, which is 2 meters. The total height of the room is the sum of the cylinder's height, 2R, and the hemisphere's radius, R. Answer: total height of the room is 6 meters. Or, an empty cone is of radius 3 centimeters and height 12 centimeters. Ice cream is filled in it so that the lower part of the cone, which is 1/6 of the volume of the cone, unfilled, but a hemisphere is formed on the top. Find the volume of the ice cream. Take pi is equal to 3.14. Concept: volumes of cones and hemispheres. Explanation: the volume of the cone is calculated as 36 pi centimeter cube. The volume of ice cream inside the cone is 5/6 of this total, 30 pi. The volume of the hemispherical top with the radius 3 centimeters is 18 pi. The total volume of ice cream is sum of these two parts. The volume of ice cream is 150.72 centimeter cube. And now we move on to section D. This consists of 4 long answer LA type questions of 5 marks each. If a line is drawn parallel to one side of a triangle to intersect the other two sides at distinct points, prove that the other two sides are divided in the same ratio. Concept: basic proportionality theorem, Thales theorem. Explanation: the proof involves a triangle where a line is drawn parallel to the base. By constructing altitudes with the subtriangles and comparing the ratios of their areas, it can be demonstrated that the segments created on the two sides are proportional. Answer: prove that the other two sides are divided in the same ratio. Question 33. The angle of elevation of the top of a tower 24 meters high from the foot of another tower in the same place is 60 degrees. The angle of elevation of the top of the second tower from the foot of the first tower is 30 degrees. Find the distance between the two towers, the height of the other tower, and the length of the wire attached to the tops of both towers. Concept: applications of trigonometry, heights and distances. Explanation: let the distance between towers be x and the height of the second tower be h. Using tan 30 degrees is equal to h divided by x and tan 60 degrees is equal to 24 divided by x, we find x is equal to 8 square root of 3 meters and h is equal to 8 meters. The length of the wire BE is calculated using the distance formula between the tops, resulting in, pay attention, square root of x square plus in brackets 24 minus 8 square, which is equal to square root of 192 plus 256, which is equal to square root of 448. Answer: distance is equal to 8 square root 3 meters, height is equal to 8 meters, wire length is equal to 8 square root of 7 meters. Or we have another question for you. A spherical balloon of radius r subtends an angle of 60 degrees at the eye of an observer. If the angle of elevation of its center is 45 degrees from the same point, prove that the height of the center of the balloon is square root 2 times its radius. Concept: trigonometric ratios and geometric properties of circle. Explanation: let the observer be at point B. The balloon subtends 60 degrees. So the angle between the observer's line of sight and the center is 30 degrees. In the right triangle, formed by the radius and the distance to the center OB, sine 30 degrees is equal to r divided by OB, giving OB is equal to 2r. In the vertical triangle, the height of the center OA is related to OB by sine 45 degrees, which is equal to OA divided by OB, leading to OA is equal to OB divided by square root of 2, which is equal to 2r divided by square root of 2, which is equal to square root of 2r. Answer proved. And now moving on to question 34. A chord of a circle of radius 14 centimeters subtends an angle of 60 degrees at the center. Find the area of the corresponding minor segment and the major segment of the circle. Concept: areas related to circles, segments. Explanation: the area of minor segment is calculated as, in brackets, area of sector minus, in brackets, area of triangle. For a 60 degrees angle, the triangle is equilateral. The calculation is 60 divided by 360 multiplied by pi multiplied by 14 square minus square root of 3 divided by 4 multiplied by 14 square, which simplifies to approximately 17.9 centimeters. The major segment area is found by subtracting the minor segment area from the total circle area, which is pi by 14 square, resulting in approximately 598.1 centimeters square. Answer: minor segment area approximately 17.9 centimeters square, major segment area approximately 598.1 centimeters square. And now we come to question 35. The ratio of the 11th term to the 17th term of an AP is 3:4. Find the ratio of the 5th term to the 21st term and the ratio of the sum of the first 5 terms to that of the first 21 terms. Concept: arithmetic progressions, terms and summation. Explanation: from the ratio a plus 10d divided by a plus 16d is equal to 3 divided by 4, we solve to find a is equal to 8d. Substituting a in the ratio of the 5th to the 21st terms, in brackets a plus 4d divided by a plus 20d, gives ad plus 4d divided by ad plus 20d, which is equal to 12 divided by 28, which is equal to 3 divided by 7. The ratio of the sums S5 divided by S21 is calculated using the formula n divided by 2, in brackets 2a plus, in brackets n minus 1, close brackets d, which simplifies to 25 divided by 189. So the answer: a5 is to a21 is equal to 3 is to 7, s5 is to s25, s5 is to s21, which is equal to 25 is to 189. We have another alternate question for you. 250 logs are stacked such that there are 22 logs in the bottom row, 21 in the next, 20 in the next, and so on. In how many rows are 250 logs placed, and how many logs are there in the top row? Concept: arithmetic progression, summation. Explanation: this forms an AP where a is equal to 22, d is equal to minus 1, and Sn is equal to 250. The sum formula: 250 is equal to n divided by 2, in brackets 44 plus, in brackets n minus 1, in brackets minus 1, leads to quadratic equation n square minus 45n plus 500, which is equal to 0. Factoring gives, in brackets n minus 25, in brackets n minus 20, which is equal to 0. While n is equal to 25 in a mathematical solution, it would result in a negative number of logs in the top row. So n is equal to 20 is the valid answer. The top row has a20 is equal to 22 plus 19 in brackets minus 1, which is equal to 3 logs. Answer: 20 rows, 3 logs in the top row. And now we come to section E. This section comprises 3 case study based questions carrying 4 marks each. Question 36, case study 1. While designing a school yearbook, a teacher requests that the length and width of a specific photo be increased by X units each to double its original area. The original photo measures 18 centimeters by 12 centimeters. 1. Write an algebraic equation depicting the above information. 2. Write the corresponding quadratic equation in standard form. 3a. What should be the new dimensions of the enlarged photo? Or B. Can any rational value of x make the new area equal to 2220 centimeters square? Concept: applications of quadratic equations. Explanation and pay attention. I know it's the end of the paper and you want to move on to the next, but pay attention. The original area is 18 by 12, which is equal to 216 centimeters square. Doubling this area gives 432 square centimeters. 1. The new dimensions are 18 plus x and 12 plus x. The equation is 18 plus x, 12 plus x is equal to 2 in brackets 18 times 12. 2. Expanding and simplifying leads to x square plus 30x plus 216, which is equal to 432, which in standard form is x square plus 30x minus 216, which is equal to 0. 3a. Solving the quadratic equation x plus 36, x minus 6 is equal to 0 gives x is equal to 6 since x cannot be negative. The new dimensions are 24 centimeters by 18 centimeters. Now, b. If the new area is 220 centimeters square, the equation becomes x square plus 30x minus 4, which is equal to 0. The discriminant d is equal to 916 is not a perfect square, meaning no rational value for x exists. Our answer is 1. In brackets 18 plus x, in brackets 12 plus x is equal to 432. 2. X square plus 30x minus 216 is equal to 0. 3a. 24 centimeters by 18 centimeters. And 3b. No. Question 37, case study 2. The India Meteorological Department analyzed seasonal monsoon rainfall across different subdivisions in 2018 as shown in the following table. Rainfall in millimeters. 200 to 400, number of subdivisions 2. 400 to 600, number of subdivisions 4. 600 to 800, 7. 800 to 1004. 1000 to 1200, 2. 1200 to 1400, 3. 1400 to 1600, 1. And rainfall millimeters 1600 to 1800, number of subdivisions 1. Now, write the modal class. 2a, find the median of the given data, or b, find the mean rainfall in the season. And 3, how many subdivisions had good rainfall, at least 1000 mm. Concept, statistics, mean, median, and mode. Explanation. The modal class is the interval with the highest frequency 7, which is 600 to 800. 2a. Total frequency n is equal to 24. The median class n by 2 is equal to 12 is 600 to 800. Using the formula, the sources calculate the median as 771.4 millimeters. B. Using the midpoint xi for each class, the total sigma fi xi is equal to 20400. The mean is 20400 divided by 24, which is equal to 850 millimeters. 3. Subdivisions with greater than or equal to 1000 millimeters of rainfall are found by adding frequencies from class 1000 to 1200 onwards. 2 plus 3 plus 1 plus 1, which is equal to 7. Answer 1, 600 to 800. 2a, 771.4 millimeters. 2b, 850 millimeters. 3, 7 subdivisions. And now we come to our last question, question 38, case study 3. In a discus throw event, the discus travels along a tangent to the circular spin orbit upon its release. In the provided figure, AB is a tangent to a circle of radius 75 centimeters with center O. Given angle ABO is equal to 30 degrees and PQ is parallel to OA. A, find the length of AB, and B, find the length of OB. C1, find the length of AP, or 2, find the length of PQ. Concept, trigonometry and properties of tangents. Explanation. A. In right triangle OAB, tan 30 degrees is equal to OA divided by AB, which is equal to 75 divided by AB. Thus, AB is equal to 75 square root 3 centimeters. B. In triangle OAB, Sine 30 degrees is equal to OA divided by OB, which is equal to 75 divided by OB, which is equal to 1 divided by 2, giving OB is equal to 150 centimeters. C1, since OA is equal to 75 centimeters and OB is equal to 150 centimeters, QB is equal to OB minus OQ is equal to 150 minus 75, which is equal to 75 centimeters, making Q the midpoint of OB. Because PQ is parallel to OA, by intercept theorem, P is the midpoint of AP. Thus, AP is equal to, in brackets, 75 square root of 3, close brackets, all this divided by 2 centimeters. 2. Using similarity, triangle BQP is similar to triangle BOA. The ratio PQ divided by OQ is equal to QB divided by OB, which is equal to 75 divided by 150, which is equal to 1 divided by 2. Thus, PQ is equal to 75 divided by 2 centimeters. Answer A, 75 square root of 3 centimeters. B, 150 centimeters. C1, 37.5 square root of 3 centimeters. And C2, 37.5 centimeters. And with this, we complete our Maths 2023 paper. Hope you enjoyed it. Follow us for more.